Hello everyone, welcome back to another video of data science series. Today we are going to see what are neural networks and how we can implement neural networks in Python. So let's see what is neural network. Imagine your brain has lots of neurons and how they communicate with each other. It is similar in computer or in the context of artificial intelligence or data science. A neural network is a simplified model inspired by human brain. It is designed to recognize pattern and make decision based on data. As we can see, this is a human neuron containing cell body, axon, and dendrites. But in artificial neural model, it contains input layer, output layer, and in between hidden layer. We can see the each cell representing data is called node. So let's say W1A. In this, node 1 is connected to node A and node 2 is connected to node A also. And node 2 is connected to node B. Similarly, every node is connected to each other. As we can see, the input layer contains three nodes, the hidden layer contains one node, and the output layer contains only one node. It begins with only it begins with three nodes and gets easily and gets converted into one node. That's how miraculous is decision neural network. So let's see an code example. Okay, we have imported following libraries: sklearn, NumPy, Pandas, and Keras. Keras is a machine learning library which is used for a higher computation and topologies. In the sample data, we have collected random data, feature 1, feature 2, and target, which will probably give us an empty data set or list on further neuralizing the network. We have created a data frame and stored in a variable called df. We will pre-process the data, meaning splitting, almost to splitting x, y. In this, we have stored feature 1, feature 2 to x and target to y. Now we are going to categorize y, convert target to categorical. We are converting this target variable to categorical. Next, we will split the data. As I said, preprocess also contains splitting the data. Now we will split the data based on train text split imported from sklearn model selection library. Next, build neural networks. First, we have to create our object of sequentials. Then we are going to add dense 12 nodes, input dim, activate, activation ReLU, and again activation ReLU, and again next softmax. These are just activation keywords. Next, we are going to compile the model based on the previous output. We are going to compile all these three networks or 12 nodes, 8 nodes, and 2 nodes based upon this. Categorically cost entropy. This will compile based on cross entropy and leaving behind it. Next, we are going to train the model or transform the model. In this, we will write model.fit, xtrain, ytrain, and epulse which are 50 means there will be 50 over 50 iterations, and batch size equals to 1 means almost 500. Next we are going to see Y prediction and Y prediction classes. In this neural network, each class is predicted equally. We can see that model that predicts X test. We are giving X test variable to Y prediction and Y prediction classes to argument max of Y prediction, and then we are going to give Y test to Y test classes prediction. Next we will be printing classification report and accuracy report as we all do in evaluation of model. Let's take a look at the output. We can see that for millisecond step, the accuracy is the loss is gradually decreasing as we have seen in the following output. But the accuracy is skewed all over the place. So we can say that over the next training of the model, loss is decreasing, but the accuracy is getting skewed. And the classification report says support is 11, 19, and 30, 30, which results to 30. Means accuracy is almost 50%, and F recall value is 64%, and precision was 39% for first iteration, and for second 67%, which is under the limit, which is pretty good. As we can see, we can also use keyword variable length argument